And good afternoon, everyone. Thanks for joining us again. My name is Zach Allison with ATS. This is our ATS University and our ATS webinar series where we talk about many of the manufacturers and sponsors of our illustrious spec tool. If this is your first time joining us, I always say thanks for giving us a shot. There's a lot of various information and webinars and series out there, and we try to provide topical application specific webinars and sessions to just make sure everyone's getting their questions answered. If this is your first time, ATS is a online product selection, online product configuration tool. It's free for engineers, design build contractors, architects, interior designers. Provides you a service that you can actually configure the product that you're looking for, not just get a generic spec, get the exact model name and number that you need, include all the suffixes and options that you need. And then we provide about 10 different deliverables, whether you need a long spec, a short spec, a schedule in Excel, PDF submittals, Revit files, everything in between. We've got new options on all those formats launching in the near future where you can toggle, different features to get the download exactly as you like. And I'm sure there'll be another deep dive session where we go into that. So I'm not going to waste too much of our time today talking about the spec tool, but we will get there at the end. After this session, I always like to show how you can find the product that we're talking about today on the spec tool. So I'll show you how you can find that and navigate the system to find exactly what you need. If you would like a deep dive after this session, feel free to reach out to me, Zach at atspec.com. I manage our market development team that works with engineers all across North America to make sure that we can help get your masters set up on the system, ease the time it takes to implement this system into your workflow, which is really our end goal. Our goal is to provide the ease of product selection in formats that fit how you're already issuing your book spec or your written spec or your PDF drawings, and just get you the information as best we can. The other big part of what our market development team does is work with you and your team to understand the products that are on the system. And that's really where our webinar system comes in. That's where one-on-one meetings come in, and that's where lunch and learns for your firms come in. So if you're interested in more of the subject, again, reach out to myself. My team and I will work with you to help you get set up on the system or get you set up with a lunch and learn on the topic. Some of the topics that we cover are, ASPE accredited or AIA accredited, depending on the topic. We've done application-specific overviews where, we were talking about the Blue Jays Skydome renovations earlier, and that would be more of an application-specific discussion where maybe we're talking about the variety of products that are on the ATS spec tool and how it fits a stadium application. Today, we're really kind of doing more of a deep dive. We're going to focus on corrosive waste and neutralization. This ties into a larger category specific month that we're focused on. We're calling it pipe month internally. I think we've had PEX discussions, we've had stainless discussions. We're diving into, chemical resistant discussions here. Wide variety of piping products even on the system these days, which if I see some of the names in here that have been with us for 10, 20 years, as long as I've been with the company. So you've seen how many manufacturers we've added over the years. And this is just another realm that we're starting to get into and trying to start clean up the product selection, product configuration of these types of products. So we're going to have our partner here, Owen Dwyer, who, technical guru, national expert, national specification expert, I think is the title these days. Something along those
Along those
lines.
lines, yeah.
Yeah, I've been working with Owen for, I think as long as I've been with ATS now, so 17, 18 years. And we always have great discussions. There's a lot of back and forth and questions. So if you have questions along the way, pop them into the chat field or the Q&A field. I'll bring them up to Owen as we go through the presentation. And again, if there's anything that we want to circle back to in a one-on-one later, feel free to reach out to me and we'll set up those sessions. I do believe this is not necessarily ASPE accredited, but we will have our continuing professional development hours. We have a little certificate of attendance that we send out. So if you do self-reporting, a number like Ontario, I think BC, and a couple of the other provinces accept those kind of self-reporting for your technical training hours. So this will fulfill into that. So with all that being said, thanks for joining us, Owen. Once
Hey.
again, we're going to dive into the realm of the SMS products. I know we did trap seal priming, water hammer arresters,
hmm
2 months ago, 3 months ago now.
Yep,
So
something like
now we're
that.
going to dive into more of our corrosive waste and neutralization world.
Yeah, thanks, Zach. For those that I've met before, have joined in previous presentations, welcome back. Again, as Zach mentioned, Owen Dwyer with SMS. I'm the National Technical and Specification Manager with SMS. Been here for going on 14 years, and prior to that, I was with IPEX for almost 15 years as their technical sales specialist. I'm also the chapter president for the Toronto ASPE chapter. So my presentations are geared towards, I want you to take something away from it. It's on a technical sense. This is by no means a way of selling anything to you. There is, as Zach mentioned, 81 slides. A lot of them are just kind of for placeholders or pictures, but um, aside from introducing myself, we'll kind of jump right into the meat and potatoes. So again, it's going to look very wordy as I go through the presentation, but I'm just kind of zooming in on some of the code sections that we'll talk about. So again, it's a two-part presentation. First part's going to be on the piping systems with respect to corrosive waste, and then we're going to dive into the neutralization system. So different types of neutralization systems, passive and active, as well as the terminology dilution and whatnot in our code. So when it comes to corrosive waste with respect to our code, what does it say? The first part you could find in 2211. And what it's talking about in the second point here is materials and equipment that are used in a drainage system where excessively corrosive wastes are present shall be suitable for the purpose. So right there, again, it looks very wordy. On the right-hand side is the code section I'm referencing. But you're not going to just put anything willy-nilly into these systems. You have to make sure that it's going to be chemically compatible with the piping system that you are ultimately selecting. Everything in there from the stainless steel to the gasket material, et cetera, et cetera. So the crux of it in 2281 or 7281 in the OBC, they're verbatim. There's no word changing. So with respect to pipe and fittings, it says where pipe and fittings are used in a drainage and venting system for acid or corrosive waste shall conform to. So shall means must. So we are a codes-based system. So it lists ASTM A518, and that's a corrosion-resistant high silicon iron casting. ASTM C1053 borosilicate glass, and then lastly your plastics and C to that CSA B181.3. Those are the only permissible options. So you can't use a stainless steel or a PVC or ABS or whatever. It has to be certified to these listed standards. Word of caution, there are a few manufacturers that make a CPVC DWV product in the marketplace that do fall under this category. If you see on the right-hand side, and again, I'm not pointing out or bashing Spears, for example, but if you look in the second line halfway through, it says that they are compliant to CSA 181.2. So even though they say that they are a corrosive waste system, they are not showing any compliance to the CSA 181.3, which is the required standard for use here in Canada. There are, as far as I know, only two manufacturers of a CPVC DWV so far, and only one of them has the 181.3. So be cognizant of that when you do have a contractor or somebody submitting a request for alternative. If you've specified polypropylene or another material, for example, just be cognizant of that. It goes on to talk about venting. So venting in 2553, basically this section points to the separation of the corrosive waste vent from the standard sanitary. So you never tie the two together. Way back in the olden days, they allowed you, I think it was 10 or 15 feet of corrosive waste venting, and then you tied back into the sanitary. But what was happening is that corrosive vapor was recondensing into a liquid again and corroding the cast and the copper. So independent venting. So that doesn't mean that everything that's vented, you're going to have 1,400 holes through the roof. They are independently vented from sanitary. Our code then continues on in 2577. And the point that we're talking about here is the second point. The size of every vent pipe for a sewage, sump, or dilution tank shall be not less than 2. So if you have a small under-counter neutralization system that is being used for a single sink, it has to be vented and the minimum vent sizing is 2 inch. And then if you do have a larger system, just say, for example, you've got a main neutralization system in your facility, the vent sizing doesn't need to be any greater than 4. So I'm going to stop here for a second, just talk about dilution tanks. You'll see the term dilution tanks used in conjunction with neutralization. We'll talk about the neutralization, but whenever you're talking about neutralization, keep in mind that it's also encompassing neutralization and dilution are one and the same thing. So we've talked about the pipe material selection, we've talked about the venting independently, and we've talked about vent sizing. So all of that said, you also have plenum applications where you have to meet at 2550 flame and smoke. You've got vertical shaft applications where anything in a vertical shaft that is in that space where there's no floor separation, so you can't fire stop between the first floor to the 10th floor, for example. That's the definition, roughly, of a vertical shaft. Nothing is permitted in that space that is combustible. So regardless of it meeting flame and smoke, you're not allowed to put something in that in that vertical shaft space that is classified as combustible, which is basically all plastics. So again, keep in mind that sometimes the building itself will dictate where you can and can't use something. So again, it's not only the flame spread, smoke development, but it's also its combustibility. So this section here in 3643 talks about that non-combustible construction with respect to plenums. And so going back, I'm going to reference A, B, and C. So this is just that 2281 of that A, B, and C that we just saw earlier. So of the A, the high silicon iron casting, it's non-combustible. So silicon iron, it's a casted material. It was made by Flowserve, and you can tell by my wording I'm selecting, it's past tense. So Flowserve was the manufacturer of the Duriron product. Duriron was that product. It was a no-hub style assembly, had special gaskets, special materials, but unlike products that are available today, it was discontinued in April of 2016. So if it is something that is on your master spec, get rid of it. It doesn't exist anymore. So to its praise, it was the inception product almost over 100 years ago for corrosive waste. So they added extra silica sand to that casted material to prevent, unlike similar cast iron, for example, that addition of silica sand made it a bit heavier, but it allowed it to have a higher corrosive resistant property. So what we have to do today is transition. So again, must be suitable for the purpose. We're not throwing in a Fernco coupling in a corrosive waste system unless it's appropriate for the application, because I do believe Fernco does make some corrosive waste products. But again, there's Mission Coupling, Dallas Specialty, Fernco. Make sure that transition from that old dinosaur bone of Duriron that you accidentally dig up on your job site is transitioned properly. So of the A, B, and C, that's the A. Again, it's still in our code, it's still referenced, but it does not exist. So sadly, it's taking up some valuable word space in our code, but bringing us to B. B is the borosilicate glass to that ASTM C1053. So glass is also non-combustible. So it is a product that is, again, if you think of a laboratory environment, you have beakers and test tubes and flasks and all of that. Those are all made of the same material. It's not the same glass that you would have as your wine glass or your typical glassware at home. It is a high silica content recipe, if you will, for the glass. And it is basically that flask and beaker transitioned into a piping system. So very, very high temperature, corrosive resistant properties. Unlike plastics, it's made by skilled tradespeople. So imparted in that as some of the cost for glass. I'll talk about a unit value comparison later. But just imagine that every single elbow, every branched Y, every P-trap is made by a skilled tradesperson using a jig and a torch and bending the glass or using carbon rod to weld branches on, et cetera, et cetera. So glass is non-combustible. It's kind of born from fire, if you will. Only available up to 6. And there are 2 joining couplings. There's a bead to bead. So every end of a glass fitting or every end of glass pipe has a flare or a bead on the end of it. You can see in the previous kind of line drawings here. And then there's the B to plane. So the plane is obviously when you cut your pipe to suit your length on site, you have a planed end piece, and that's your bead to plane. So a fitting end or another beaded pipe end to the plane cut end. Again, line drawing depicting how they work. The bead to plane end, luckily for all the other plastics options on the marketplace, are all made to IPS OD. So sometimes, or very frequently, the bead to plane coupling in the glass application is used as that transition. So suitable for the purpose. It's iron pipe size, and it's elongated to give some of that grip on the pipe surface. I'm going to zip back to the picture here. The white component in the center is made of Teflon. So it is, as we know, Teflon is very, very inert to most chemicals. And the black is a Buna rubber. The white is the wetted component. The black is basically the grip, if you will. So it's helping kind of give you some, not necessarily adhesion, but some surface grip and tension on the glass material. So this leads us into C of the A, B, and C that I talked in 2281 or 7281. So the plastic corrosive waste systems are again under the CSA B181.3. And because they're plastics used in non-combustible construction, they also have to have compliance to either the flame spread or the flame and the smoke if it's being used in a plenum. So plastics are all classified as combustible. As I mentioned, that vertical shaft option, that is the only permissible space where you can use, or sorry, if you have a corrosive waste application in a vertical shaft, there's no other option. We can't use stainless steel because it doesn't meet A, B, or C. So the only option, it's very rare that you'll see a vertical shaft in a laboratory space. Typically, they are boxed in or within a rated assembly. But if, for example, you're doing a retrofit or a reno and you do have a vertical space, not to be confused, a vertical shaft is not the same as a pipe chase. A pipe chase has a floor separation where you can fire stop, whereas a vertical shaft is free and clear from top to bottom. So don't let those two terms confuse you. So glass would be your only option in a corrosive waste application in a vertical shaft because it's the only one that ticks that box for you. Plastics, again, flame spread rating and smoke development classifications. There are a special provision for polypropylene because polypropylene is very inert to a broad list of chemicals. It is very suitable for the majority of laboratory type applications with temperature and chemical. Where it does not meet the standard code is on its flame spread rating. So don't ask a polypropylene manufacturer that's providing polypropylene on a project to provide you with a flame spread rating because it doesn't exist. And what's happened in, I believe it was the mid to late 90s, there was only glass and duriron, and then there was this kind of risk assessment approach to what material was going to be selected. Polypropylene was added back at that time because, again, as its ability to have high chemical resistivity. But what they had to do is they had to change or add this provision in the code in 31519 under combustible pipe materials. It says where polypropylene pipes and fittings, they're permitted to be used for drain, waste, and vent, for the conveyance of highly corrosive materials, and for the piping used to distribute distilled or dialyzed water. So that's your pure water piping, your RO or DI water in a lab. That piping also is permitted to be polypropylene in these buildings that are hospital facilities and laboratories that are required to be of non-combustible construction. So again, what that is emergency egress, hospitals, people that are confined to beds, plenums are shared ceiling spaces. So it's all about emergency egress. But because polypropylene is so good at the chemical resistance DWV part of it, they made this special provision that the building has to be sprinklered throughout. So if you're doing an application where there is no existing sprinklers, if it's an old high school, for example, and you need to meet a flame spread rating because it's a non-combustible building, but that building does not have sprinklers. And there's also some terminology in here where it says sprinklered throughout. So some authority having jurisdiction may consider an attached renovation to an old building that does not have sprinklers and the new building does, it is not throughout. So Be careful there as well. So if it is a retrofit, make sure that the building is sprinklered if you're specifying polypropylene in that application. And then again, it goes on to say that the piping can't be located in the vertical shaft, and it's cut off here, but there's a C that says that you have to have a certified fire stop device. So be it caulking or a listed Hilti 3M ProSeal, et cetera, et cetera. So that said, there's various plastics acid waste manufacturers on the market, but they all have to conform to CSA 181.3. Predominantly, you're going to see electrofusion or mechanical joint, and every manufacturer has their nomenclature. There's Enfield, there's Lab Line, there's Plenum Line, there's Brown Line, Blue Line, White Line, uh, et cetera, et cetera. So just be cognizant, not only when you're specifying something, it's always best to specify the standard. We are a standards-based code system. So again, specify the standard that's applicable, not the trade name. The trade name kind of eliminates proper competition, et cetera, et cetera. So it's always best just to cover your behinds by specifying the actual reference standard. Just some nomenclature. FRPP stands for flame retardant polypropylene, non-flame retardant polypropylene. And then PVDF, you can see why people refer to it as PVDF, because polyvinylidene fluoride doesn't roll off the tongue as smoothly. Pardon me. So as I mentioned on the onset, as far as unit value comparison, if glass was your unit value of one, because it's, as I mentioned, it's going to be the most costly, because again, that labor factor. So if you'd have a pipe and fitting takeoff, and it's glass, for example, you take glass as your unit value of one. PVDF is about 25% less than glass. You can get PVDF in glass jobs that are equally priced, but as you can imagine, if it's a fitting intensive project with glass, those couplings will all add up. So every job is different, but a standard rule of thumb is PVDF is going to come in and around 20-25% cheaper. And polypropylene, you can see why the special provision was made, because it does tick very many boxes with respect to chemical resistance, but it's a third the price of what was available back in the day. And you can see why Duriron has gone the way of the dinosaur. It was 3.5 times that of a typical glass project. It's very heavy, very cumbersome material to work with. So, and it's 10 times more than the polypropylene product when polypropylene came into the market back in the 90s. So everything has to be suitable for the purpose. So this is just some shots of different transitions that are available. As I mentioned, Fernco does have product available. Dallas Specialty Couplings have a product available. Mission Rubber has a product that's available. And then you have your standard threads, flanges, et cetera, et cetera. So if that's your transition piece and you don't trust a mechanical rubber type of connection, you can always specify a thread or a flange. So where are you going to find these acid waste systems? You're going to find them in schools, less so to lesser extent on the high school side, because you're dealing with like vinegar and baking soda, that type of, you're not high-end chemicals, but definitely hospitals and universities. Industrial applications, absolutely. Pharma is a no-brainer. Food and beverage is often overlooked for corrosive waste. You have a few methods of sterilization and sanitization, and that's either temperature or chemical. And when you come into high temperature and chemical usage, you are very often talking corrosive waste. So going back to the 2281, the A, B, and C, as I mentioned, you shall conform to. So we have to look at these piping options. We can't look at polypropylene, or sorry, stainless steel or ABS or PVC or any other material that's not listed. There's a completeness of the product lines: combustible, non-combustible, returner, plenums, and shafts, etc. And these are advanced engineered systems. So again, it's not like you're off the shelf. You're not going to find any wholesaler anywhere across the country that's typically going to have any of these product lines, for example, because it's just not something that, it's not like an ABS or a PVC, for example. So these are specialty products. I'll pause for a quick sec for a sip of my water before I jump into neutralization. Anybody have any questions so far on the piping systems?
Actually, we haven't. We've had pre-questions come up for,
Mhm.
I think, the neutralization category.
Okay.
And I'll prime it here. I'm sure you'll kind of get into it, but it was asking more about when you have a drain in the chemical storage area,
Yep.
and a local plumbing inspector is saying that it can't be run to the regular SAN.
Correct.
So understanding that perspective, and I think that comes in where it needs to be neutralized before it gets into the sanitary.
Yep.
And I think you'll cover
100%.
that here. So,
I
uh,
could talk about it right now with respect to the industrial type application that I mentioned in the previous slide here. Some of these industrial applications may not be, top of mind for corrosive waste, but those could be chemical storage closets, chemical storage rooms where you do have the potential for a chemical spill. A lot of industrial applications, for example, they use battery-operated forklifts. Battery-operated forklifts in a warehouse, they all have a central charging station. And in the event during charging that there's a battery failure, that's sulfuric acid that's going to be spilling onto the floor, and there's going to be floor drains or a trench drain in and around that area for that exact reason, or wash down, that type of thing. You're not tying that into your sanitary directly without going through a neutralization system first. So that's a good example to talk about industrial applications or for chemical storage closets. So that stainless steel drain, for example, or the epoxy coated drain that you're going to specify should go into uh, a, a piping system that's
appropriate piping
certified
system.
for that sulfuric acid, for example, at that concentration to a small neutralization tank that's buried in that area. And then again, anything downstream of that is now neutral. So you're now back to cast or copper or PVC or whatever your concrete, whatever your drainage system is at that point. But that's a good question to bring up at that point.
And in this particular application, it's actually was, a thing that you might not consider needing neutralization for.
Exactly.
The pool area and the chemical storage for the pool chemicals.
Yep. Yep.
Even
Exactly.
community centers, high schools, universities, like you showed there, if they have the pool and they have the chemical treatment for said pool, that would still classify. Whether or not the pool guys tell us that they're not slobs who wash down the chemicals, it's not as much a concern about their particular habits as it
Yep.
is the case of extreme failure.
It's
You could
also
even
what's
you could even reference, say, the for the engineer, if you're trying to help them understand, you could reference the neutralization that's required for a forklift battery.
yep.
It's not about whether or not they're mishandling the battery. It's the fact that if there is a leak, then there's this challenge. If
Right.
there's a leak in the chemicals that are treating the pool, that is exactly what this is being designed in preparation for.
Right. And the point that I want to note before we jump into the neutralization too is sometimes you can satisfy the AHJ by putting in a curb in a specific area. So you're containing it. So if you're connected to sanitary, that's when you have to neutralize. And I'm going to talk about that in the next slides here coming up. But you could isolate. So isolation or capture is also suitable in those instances if you don't have access to a drain neutralization system, et cetera, especially if it's an afterthought.
Perfect.
So any other questions on the piping, Zach? Okay.
I
So
think we're good to go.
just a quick recap. So piping gets a lot of love. We talked about 2281, where you have the A, B, and C listed. 31519, that's your combustible construction, uh, the combustible piping and non-combustible construction, and the provisions made for polypropylene. 3643, you have plenums. We talked in 2553 about the vent requirements through independent venting. And then we talked about vent sizing in 2557, which talked about minimum 2, max 4. So what piping also is going to take into consideration is the vertical shaft, as we've covered, the fire stopping. Again, you must fire stop if you're penetrating any rated assembly, be it combustible piping or non-combustible, but non-combustible piping requires slightly different, intumescent fire stopping devices of sorts for that, your pipe slope, etc. When it comes to neutralization in our code, this is the section here in 2444, where you have a fixture or equipment that discharges corrosive or acid waste. It shall, again, means must, discharge into a neutralization or dilution tank. There's the interchangeability of those two terms. That is connected to the sanitary drainage system through a trap or an indirect connection. Two, Neutralization and dilution tanks shall have a method for neutralizing the liquid. Period, full stop. So unlike a lot of other sections in our code where it has a standard that's referenced, there is no referenced standard. So what does that mean? These are engineered designed systems. So we have to pause here and take the time to look at temperature, chemical, location, sizing, etc. So what is the definition of corrosive waste? It typically is dependent on the sewer use bylaw. So every municipality, whether you're in Calgary or Moosonee or in Windsor, Ontario, every municipality will have some published information with respect to their pH discharge limits. If you are outside of those permissible parameters, they want you to neutralize it 100%. Chemical, it's not necessarily downstream. There is a definition in the code with respect to uh, the effect that it has on metal, on iron. I don't know exactly what that definition is, but for sake of argument, let's stick to the fact that the sewer use bylaw is going to slap the hands of people that are outside of those permissible sewer use bylaw parameters, and they impose quite heavy fines. And it's a reactive approach. So if there's a digestive issue, for example, at the waste treatment facility, they will start to go back to the sewer, the manhole covers, take grab samples, and kind of work their way backwards to find the guilty culprit. And then they'll often cite fines, give 24 hours or a certain amount of time to fix the issue. But a lot of municipalities will disallow in writing not to use dilution in that in a neutralization type of a sense. So going back to what I said, how the terminology is kind of used interchangeably in our code. My background is in biology, in the sciences, and when I was in labs, that's what we did back in the day, 30 plus years ago, was when we had your chemicals in your beakers, you turned the cold water faucet on the lab sink, dumped your chemicals down, and my prof at the time said the solution to pollution is dilution. And sadly, that's what we did. So the term dilution in our code is reserved for very specific applications. And I'll just mention dialysis for example. You don't want to put dialysis through limestone. I'll talk about that shortly, but we're talking neutralization in a corrective sense with respect to chemical treatment, not by using water, because it's a waste of natural resources. Most bylaws don't prohibit it, but in the grand scheme of things, what you're doing is, just say you have an alarm going off that your pH is below 5, and then I turn some water on. I haven't done anything to it. I've just flushed it out of my system. So it's that kind of NIMBYism approach to dealing with this corrosive waste. So what we need to think is based on the pH scale. So if you have taken you kind of back to grade 7 science class here, anything to the left of 7 is acidic, anything to the right of 7 is alkaline or basic, and that 7 is that kind of neutral. So we're not trying to neutralize. We're not trying to get to 7. We're trying to satisfy the sewer use bylaw. But just again, talking about dilution, if you look at this, every change in number is what's called a decade unit. This is a logarithmic scale. So what does that mean? pH 6 is 10 times more acidic than pH 7. pH 5 is 100 times more acidic than pH 7. pH 4 is 1,000 times, so et cetera. So if you follow those numbers, if I had a beaker of a pH 1, very strong muriatic acid, for example, and if I wanted to change its acidity or its pH concentration to neutral, let's pick 7, for example, I'd have to use 1,000,000 liters of water to change that 1 liter pH 7 based on that logarithmic change. So 1,000,000 liters less a liter. So again, trying to wrap your head around why we don't want to consider water in terms of treating acidic waste. We want to use a neutralization system that uses either a passive aggregate of some sort, like a media, be it magnesium oxide or calcium carbonate, or we want to have an active injection system where we're actually using pumps and agitation and dosing systems to control our effluent. So we've all seen passive neutralization systems. It's basically a calcium carbonate limestone aggregate, and that aggregate comes into contact with the acidic effluent, and it is a solid alkaline. So it's a higher end pH 12, for example. So when it comes into contact with an acid, that acid starts to dissolve or react with that calcium carbonate limestone. And we're going to talk about how to size these systems shortly. But you can see in the image here that there's an interceptor on the left-hand side. You can see the acid waste piping system coming in. Downstream of the interceptor, you'll see the bigger tank, which is the neutralization system. That would be full of calcium carbonate limestone. You can see on the left side is all polypropylene. The vent at our 6 o'clock in that image on that big tank would be the vent. And then you can see on the right-hand side, it's cast iron, because at that point, you're no longer considered corrosive. Now you can drain with traditional materials. So these systems are only good for acids. You cannot use a calcium carbonate limestone system to neutralize an alkaline effluent. It's not going to do anything for you. So keep that in mind. The majority of applications you'll find in university, college, high school labs are predominantly acidic. Most municipal sewer use bylaws will be more lenient on the alkaline side because typical effluent from the human body is acidic, uric acids, things like that. So they are more willing to accept some alkaline on the alkaline side. But again, calcium carbonate is only good for an acidic effluent. Tank sizing. So this is kind of where the rubber hits the road. So we're all familiar with fixture unit tables in the code. 2493 gives you a list of all your fixture units. Lab sinks fall under other. So you get a 1.5 fixture unit value for every lab sink. The sizing methodology predates me in this industry, which is 30 years. I don't know what genius came up with it, but if you look at other manufacturers' literature, and by the time you do the calculation, it essentially boils down to effectively 1 gallon of retention per hour per fixture unit in the system. So once you do your fixture unit calculation to find out how many fixture units are draining into this neutralizer, you need 1 gallon per hour. So 1 gallon for every fixture unit that's in that system. So for example, you've got 60 lab sinks. You're going to take that 1.5 fixture unit value times 60, 90 gallons. So my functional, so this 90 number that I've just calculated is my functional capacity. This tank needs to hold 90 gallons of liquid. So pi r squared h is the volume of the cylinder. We're going to talk about that, but I can't stress enough how important it is in your spec to specify as much detail as possible with respect to neutralization tanks. So unlike the piping side, you're going to tick the boxes based on chemical, temperature, plenums, sprinklered buildings, vertical shafts, etc. When it comes to neutralization, when you size it, you're sizing it, especially for limestone. I'll talk about injection systems shortly. But if you're coming up with a number, you look at a manufacturer's literature, you can't find a 90 gallon. Again, keep in mind that this is a minimum. So you want to have a minimum retention of 90 gallons. So you're going to try to go up to the next size. So in this case, you're going to look for a 100-gallon tank. And this is not the empty tank. This is functional. So what does that mean? There is a 50% space usage for that stone. That limestone, that aggregate that you're adding into that tank to do the magic takes up half that space. So in theory, you need double the size that you're thinking your pi r squared h volume is. So pi r squared h volume, take half of that volume that's lost to the stone capacity, and then the remaining balance is your actual functional capacity. How much liquid is that tank going to hold? So I use this picture here. There's a hole in my bucket. Again, functional capacity. If I have, let's take, for example, a 5-gallon Home Depot bucket. If you fill it right to the brim, it's going to have the ability to hold 5 gallons. But if I drill an inlet 3 or 4 inches down, an outlet, a vent, and then I fill it to the outlet invert with calcium carbonate limestone, there's, it's not even close to holding that 5 gallon capacity in that empty sump. So don't specify the empty sump if you know what your functional capacity is. So that functional capacity is again pi r squared h less the 50% of your displacement for your stone. So for example, this is from a manufacturer's document that says this tank AN65. You can see on the left-hand side is the empty tank sump, 142 gallons, but its functional capacity, hence the name AN65, is its functional capacity. So 36 by 48, put that detail in your spec so you don't get somebody misinterpreting, oh, I need a 65-gallon tank. Because if you do pi r squared h, it's going to be a 200-gallon tank if you have a 36 by 48-inch tank. So again, your spec should kind of take that into consideration, because what we're after is this liquid capacity, your functional capacity at your outlet invert using your 50% displacement. This is a good point to pause on this kind of cutaway here, because there's no standard to conform to. Just kind of look at the guts in this system. So if this was just a 90-degree elbow, I have no opportunity to have a clean out at the top here using at that T. The bottom, if that bottom got plugged for whatever reason, students putting garbage down the drains, whatever, if you follow, for example, this AN65 right to the end, you have 1,800 pounds of calcium carbonate limestone in that AN65 tank. So nobody wants to open the top, get GFL Environmental in there to suck out 1,800 pounds of stone just so you can clear that what's called a dip tube. That dip tube is necessary because if without that dip tube, you have laminar flow. It's just going to kind of come in and go out. You're not interacting that effluent through that stone bed. So again, attention to detail, specify the interceptor. I'll talk about interceptors later and their importance. They're basically protecting that dip tube. And then the support, the stand for the interceptor, for example. I've seen cinder blocks, I've seen milk crates, and I've seen contractors suspend what would be 100-gallon capacity tank using threaded rod because they hang it while it's empty, not knowing that the thing is going to weigh 500 pounds from Hilti pins in the ceiling. So again, the more,
I
yep,
was just gonna say, like that dip tube that you mentioned, it is probably one of the most critical components. Like you talked about the
yeah,
laminar flow. The most critical element that we use to size this is the retention time, the
correct.
1 gallon per hour per fixture unit. If you go straight across, you're not getting the retention time which is what is required in order to neutralize the flow. It's the
Right.
same reason that you don't want to undersize it.
Yeah,
So
that
that is absolutely one of the most critical components that you're
100%.
right is not necessarily called out in every spec.
Yeah, and
So
that dip tube is, as Zach, you just mentioned, that allows the effluent to kind of percolate and have that dwell time contact with that calcium carbonate limestone on its way up to that outlet. So that's the way, that's the science, that's the magic behind what we're talking about here. So the importance in detail. Again, here's an example where you can see on the left-hand side, there's some boxes of stone. Specify some additional refill of limestone so they don't have to guess. They're not going to go to the garden center to find some extra limestone. You can see the inset on the right-hand side there, the picture. It shows, again, an interceptor on a steel stand. You can see that this is glass piping, so it's probably higher aggressive content. But you can see that the tank, the larger neutralization tanks, there's two of them. Why would there be two? Two tanks versus one tank. If you have an existing building where your maximum door opening is 36 or 38 inches, you're not fitting a 48-inch diameter tank that you've just calculated you need through that 36-inch door opening. So they can be split into two tanks as long as you have and maintain that calculated functional capacity and have that necessary dwell time. It could be split into two tanks. Your first tank is going to see a more usage and consumption of your calcium carbonate aggregate, your media, and the second to a lesser degree. So the maintenance might be slightly different, but again, your end result by the time it leaves that system has had the appropriate effect. Bypasses, N+1 redundancies. If you're in an N+1 redundancy healthcare, sometimes these are designated as critical infrastructure. You may need, none of this is off the shelf. So that's the point here. So whether you need bypasses, multiple interceptors, because you want to bypass one while one is being maintained, et cetera, put that in as much detail as you can in your spec. With respect to sizing of the space available, maybe you don't have the luxury of having a separate interceptor on a stand and a tank. You've been given a very small area. If your area is small, specify an internal interceptor. You're going to sacrifice a little bit of volume, so it's not as big, so it might increase its maintenance requirement, but at least you're protecting your tank and that dip tube from any foreign debris going down the system. Flush with floor. So the images that I just showed you were for above grade. It's the exact same principles that apply for a below grade system. The only thing that's going to change is the pedestrian rated cover. I strongly recommend not to put these into areas where there's an H20 live load. They're predominantly plastic. If you can put bollards around it to prevent any vehicle traffic from going on top of these things, but just think of it as a void space below. That plastic tank or neutralization tank is a void space. So you don't want it in high traffic. We often find them in facilities where they're in the loading dock area because that's easy for maintenance, easy for access. But again, make sure you put some steel bollards around that so um, there's no live traffic load. So that said, you have to construct that tank slightly different to accommodate for a 300-pound person or a 200-pound person carrying, like a wheelie cart of goods over top. So what you need to do is understand that it's pedestrian rated. You need to beef up that lid so it doesn't dish when somebody stands on it, etc. So what does that mean? Again, we're still trying to maintain our functional capacity at liquid level at the outlet. But now I have to contend with, let's say the building owner says, no, I can't, something's changed in our design here and the use of this room. I need that tank now to be over, 40 feet this way. So now I have additional developed length to get to the new location where that tank is. So now going back to this previous image, my my inlet on the left-hand side is no longer, let's say, 12 inches below finished floor. It's now going to be 22 inches below finished floor. So I'm sacrificing my capacity because my outlet has to be lower than my inlet. So what happens is some manufacturers offer extensions. You just bury the tank, and some manufacturers offer a tank size that's different with a tank that would again maintain that functional capacity. So that said, again, the last tip is don't forget to consider the door openings. You'd be surprised how many times it happens. The tank gets delivered to the site, and not only is it the diameter of the tank, but there's the flange that's on the top. So you say, okay, well, hey, I have a 36-inch tank. I've got a 38-inch door, but then when the tank shows up on the job site, sure, it's 36-inch diameter, but it's got a 3-inch flange on both sides, and it's not quite fitting, and you got your inlet, your outlet, and your vent. So again, just be cognizant of that when you are doing retrofits and you're trying to fit a tank in an existing building. It
We
does
have the
come up.
same note. The same note comes up in our water heater presentation, in our sump pump presentation from Zoller,
Yeah,
in the acid neutralizer presentation, in our interceptors
yeah.
presentation.
It's
So many
it's
times you get foiled by the door.
yeah, the door, those darn doors. So talking neutralization. So again, how do you prove or how do you maintain or how do you alarm if there is anything going on in the system? Very often there's going to be a pH monitoring system, especially if you're doing a central system. It's cost prohibitive to put a pH monitor underneath every sink. If you don't have the luxury of putting in one central system. But again, it's not a code requirement, but sometimes the building management systems today and all of the internal communications helps with respect to maintenance and alarming if you are in breach of a sewer use bylaw. You want to take care of it. What's going on? Oh, shoot, I have no calcium carbonate left in my tank, etc. So that's kind of keep that in mind as well. pH probes typically go on the outlet as it leaves the tank. So that's your passive system, your calcium carbonate limestone. This is injection. It's very much the same, going back to that pH scale where you have left is acid, right is caustic. You basically want to inject an opposite. If I have an acid, I inject a caustic, they meet towards neutrality. If I have a caustic and I inject an acid, they meet towards neutrality. So you have your untreated liquid coming in, your dosing pumps, and then your mixer, your pH level sensors, all of that stuff. If you want all those bells and whistles tied into your system. So again, where the rubber hits the road, how do we size these systems versus the 1 gallon per hour per fixture unit in the system? There are three methods. Our code pulls out two of them, and the first one is kind of a no-brainer. If you know a pharmaceutical application, for example, and they have a specific discharge rate, a clean in place process, or whatever it may be, and you know what your GPM is. So typical ASPE would say 10 GPM, a 10-minute retention time. And then what we like is a 15-minute. It doesn't change any costing with respect to your pumps, your agitators, all of that, your pH monitors, level sensors. Nothing is changed, but by making the tank slightly larger, you buy a little bit more time. So if you take your GPM flow rate, multiply it by whatever retention time is comfortable for you, 10 or 15, that's going to give you your retention time for that injection neutralization system. If the flow rate is not known, which is very, very frequent, the code sections, these code sections can be used to guide you through that sizing of an injection system. So there's two methods. If the load is greater than 260 fixture units, use 24105B. If the load is less than 260 fixture units, then use 24105. And using the hydraulic load of 900 liters for each liter per second is the calculation that's used for both of those. So I'll kind of break down an example. And again, these are just the snippets of those code sections. And I'm going to talk a little bit faster. I'm not going to bore you. I want to leave Zach a little bit of time to talk, as we talked about. But again, calculation number one, if you've calculated your fixture units in your facility to be larger than 260, this is the method. So you take your calculated fixture unit, multiply it by 9.1. That's 9.1 liters for every fixture unit under 24105B. And then you divide that by 900. 900 liters is going to give you your per second flow rate. So 504 in this example, excuse the math there, 560, and then I'm multiplying 504, but you get the idea. You take your fixture unit count, multiply it by 9.1, then I'm dividing it by 900, and it's going to give me a liters per second flow rate. I take that and I convert it to GPM, and then I'm going to apply my 10 or 15 minute of retention. Again, whatever's comfortable for you. So that gives you your 100% maximum flow for all of those sinks in your facility. Now I have to back them out. I have to back it out based on my diversity. At any given time, am I only going to be using 20% of these sinks, 50% of these sinks, 70%? Maybe you just leave it at 100, and that's the size of your system because you're adding for safety factor, you're adding for future diversity and growth of this facility, et cetera. So those are when you start to play with that number. So you've calculated your size of your tank, and then you subtract or do what you need to incorporate your diversity. Option two just takes a typical round number. So if your sink count is less than 260, it says in 24105, when your load is less than 260, a round figure of 2,360 liters is used. Again, you divide that by your 900 liters, and it gives you your liter per second flow. You do your dwell time, your US gallon conversion, and again, you apply your diversity. So what this means is if you have a single sink or you've got 259 sinks, it's going to give you the same number. It's going to give you the same size of tank for anything below 260. So again, this is a way it's a guideline, and you have to kind of use common sense when you're putting the number into actual play with regards to an injection system below 260. You might apply more diversity if that's the case, or less dwell time in your 10 or 15. You're not going to go totally overkill. So what these systems look like, sometimes you have the luxury of specifying a skid system that you kind of drop plug and play. On the right-hand side is what you'll see. All the components are the same. You have your dosing pumps, your reagents, whether it's a caustic reagent or an acid. You have your pH monitors that are doing the magic, telling the pumps what to do. And level sensors, again, interceptor stand. N+1 redundancy. On the left-hand side, if you have this massive skid system, you can see that each tank has two agitators. There's multiple pumps. So if system A, any component in system A goes down, there's some logic built in, a control that switches it over to system B, etc. But in the end, they're all the same. As far as the components, you have a reagent, you have a pump, you have your pH monitoring, etc. So scrutinize, scrutinize, scrutinize. When you get equal alternate requests and you've just calculated your fixture units in a limestone system, make sure that it's not the empty capacity. So you want to make sure you're maintaining that functional capacity. Remember, the inspector and the contractor see a magic box. This is something that is engineered for the client specifically for this application. There's people ticking boxes. So again, you have to be cognizant of the fact that the contractor is always going to try to save money. We're always under cost pressures, but sometimes the illusion of cost savings is quite rapidly dissolved when there's system issues down the road. If it's an undersized system and you didn't spend the time to scrutinize what that alternative tank looked like. I'm going to breeze through the options. We talked about below grade applications and heavy duty lids. How is that retaining mechanism taken care of? Is this the same as this? If you've got a gasket, you've got, like it's just the quality of workmanship and construction in those tanks, again, because there's no standard to say, no, you have to show compliance to the standard. You have to, again, make sure that you scrutinize as much as possible, or else you end up with this. You have a Rubbermaid garbage can and a bunch of rocks. And so this video is a very poorly made system where this very flimsy lid. And in this space, this is a copper pipeline that's being corroded by the corrosive vapors escaping the neutralization system because it's not strong enough to make a seal. So yeah, by code, can you tick a box by adding a garbage can, throwing some calcium carbonate in it, and calling it a neutralizer? Yeah, you've created a method for neutralizing the liquid, but that's not what your client is looking for. So again, spend the time to scrutinize, make a pointed form list. Hey, is it black material, for example, that's UV resistant. How long is it going to be sitting outside the job site? Because polyolefins are subject to UV degradation. Gaskets, is it neoprene or EPDM? Do I need Viton? You're not going to have zinc hardware. You want to specify stainless. Is it the empty sump or functional capacity? Calcium carbonate limestone, we recommend minimum 90% calcium carbonate because the other 10% is undissolvable solids. So if you get garbage limestone, you're going to have a smaller functional capacity, if you will. Vent sizing, we talked about pH probes, trap primer connections, interceptors, pH monitors, etc. So interceptors, basically it's a strainer that's protecting that dip tube. And what you're going to see is these three guilty culprits: broken glass, pipette tips, or litmus paper strips. So that's ideally what you're trying to protect from clogging up your neutralization system. And this is just, the proof is in the pudding here. This is a shot taken from a local college where that's exactly what's clogged there, is the pipette tips. So it should be thought of as a system. So not only is your pipe and fittings and all of that we talked about, but the neutralization system is pH monitors, injection or calcium carbonate, as well as the interceptors. So think of it kind of like as a one package. So did I leave you enough time, Zach?
You're bang on 1 o'clock. So You got through
Well,
as best as we could, I think. I will mention, I know that there's going to be a handful of people that need to dip off here. Thank you for your
yep.
time. Thank you for joining us. I am going to show how you could find and accurately specify the engineered designed neutralization tank in a second. We had a great point come up from the chat actually as you were wrapping up there. In that sort of, in that neutralization tank in the mechanical room where that's stored, if you had insulated the pipes, would that do anything to prevent against the corrosion? Is that better or worse than doing nothing, and having an incorrectly specified unit?
Yeah, I think um, that's not the solution. So to have the corrosion by wrapping them, the issue was the fact. So this was a school. I'm not going to say what school it was or whatever, but the problem was that they could not create enough of a seal in that bolting to keep those vapors contained. And because there were student lockers on the outside of that door as well, those vapors were escaping and rusting the bottom of the steel doors of the student lockers adjacent to that room. So it was a bigger issue. But yeah, just insulating the pipe would it have made a difference? Possibly. But the key issue, the fundamental issue was poor construction of that tank.
Yeah, that's for sure the key issue. Um, Thank you again for those that have joined us need to drop off. I'm gonna try to do a quick 5 to 10 minute introduction to the spec tool and how we find the products here today. Um, First and foremost, ATSspec.com. This is how you can access your free online product configurator. Again, our goal is to help you select your suffixes, select your sizes, get the exact model name and number that you need. We have new features that include new output formats. We have features that allow you to set your approved manufacturers by category, by brand. We're showing off backflow here, but this would be a great thing if you are doing, say your acid neutralization tank and you want to ensure that you have the appropriate model name and numbers of all the approved equals. This way you are limiting to the brands that you are confident in that meet your design spec. And it provides you a great verbiage that will help you ensure that even if they are an approved equal, they still have to submit their approved equal because there's a lot of different brands that have different levels to different categories, as simple as a faucet to as complicated as a backflow or a neutralization system. Make sure you get true equivalents and brands that you trust. We had a question come up, ask for the recording of this session. All of our webinars are recorded. If you go to the Architects and Engineers tab here, you can see you've got our templates, which is our recommendations by application. We have our Learning Hub, which gives you access to our knowledge base, which is like our code breakdowns, our sizing guides, and the webinar recordings, which will show you, how to size a sump pump, how to size your water heater, how to select and size your neutralization tank, right down to detailed barrier-free guides based on different applications, and then our available products that shows the various manufacturers that are available on the system. I think we're up to about 45, almost 50 different manufacturers that are on the system now. Everything from the architectural products like your soap dispensers, your grab bars, your toilet paper dispensers, right down to our heavy duty mechanical equipment, whether it be on the rooftop with your drains and piping, down through the building into our mechanical room with all the drainage system, all your backflow protection, mixing valves, and of course, as we're talking about today, neutralization. If you want to go into the webinar recordings again, that'll be shown here. You can sort through, search, and find your various categories and watch the recorded video. Once you're in and you've hit that little login button up in the top right, just like any other website these days, it'll remember your password. It also, one thing we do focus on is ensuring that you are within your organization, within your firm. So if your firm has multiple offices, you can share projects and masters across those multiple offices. You can set up different masters and standards. Your masters is just your repeat work that you're doing consistently. So I have some firms that have a BC version of their master where they've got locked tank lids and accessories. They've got their Manitoba masters, which follows the National Building Code. They've got their Ontario masters, and maybe your BC office works on different types of projects than your Ontario office. They might specialize in healthcare out west and specialize in, tenant fit ups in downtown Toronto. You can set up all those different masters, your different repeat work with your approved equals all your approved brands. So you as the team lead can set this up with your approved product, your approved brands, and then your EITs, your juniors, they can all drag and drop that into their current project. The main reason we do this is to help keep you up to date and accurate. The manufacturers pay us directly. So if the neutralization tank changes from an AN35 to an AN135, we are going to update your master and update your current projects. That current is a key word. We've got our different file folders here that you can create a quick spec, a project, or a master. Like I mentioned, the master's always up to date. The project, you'll see we ask for location and bid date. This is so we can keep your project up to date until the bid date, and we apply the local building code based on your location selection. And then our quick specs, which does not have that detail, which means that we are not applying our rule engine. So this does come into play across Canada now, especially as we have our new NRCan updates. If you have not updated your masters, there's some different applications. Healthcare have different flow rate allowances than office buildings or general public applications now, which has a different flow rate than your residential application. So your shower for your residence is going to have to be different than the shower for your office, and that's important to keep up to date. That's what our masters and projects are for. If you are just creating a quick spec, you are not getting that protection. So I've gone into the project folder here. I've got my SMS webinar demo where I added the pipe that we were talking about earlier today. And we can add product to this project folder two ways. We can go through this bright orange add product, which is going to take us to our tiles, which allows us to go into our pipe category, the identification, faucets, basins, etc., sinks. We can search for the neutralization tanks. You can see it pulls up keywords as we go. And we can size and select our neutralization tank to ensure that, we've got we'll just do a 10-gallon capacity, or we could switch over and reset and let's do, what were we saying, the 100K capacity. And you can see our model number for the recommended neutral interceptor is changing, the line size is changing, and every time we make a selection, we're updating our model name and number, updating the list price that we have. If we get into the custom options like the extension, the list price might not necessarily have that. And of course, the pH digital monitoring that we mentioned. Again, updating and getting the exact model name and number as we select every one of our suffixes. That's the critical element. We'll hit add product. And now we've sized our neutralization tank on the side. We've got the exact selection here. Any single time that we are done with our selection, it's going to be added into here where we could change our tags. We can call this AN1. We can go and edit the sizes as well. If we want to hit the edit button, we can add our alternatives and make sure that we're ensuring that it's an equivalent product. And then if we want to round out the selection, maybe this is a lab application. We want to go to our masters and templates and grab our standard lab drainage, our standard lab sinks and everything like that. We can filter down through your masters, which this is my demo account, so there's a lot of demo masters, but this would be your firm's masters, your firm's approved products for industrial applications, or for your pipe, or for your pharma, for your lead applications. So you might have a lead version of a project and then your base flow rate version of a project. And then you have the ATS templates, which is our recommendations by application so that you can simply drag and drop from our recommended product selection. So we've got a lab application here. If we need a lab sink, we can grab those and we just grab these dots and drag it over and drop it into our selection. If we want to get let's go to our industrial template here. Maybe we need some toilets and general washroom areas. We can round out that selection. And again, it's kind of hidden here because this little bar is in the way. We have this import selected products, which will import everything that you've toggled the option on, or you can grab the dots and it'll drag all of them over. So if we hit the import, it will import them into the product group. And then if we want to, again, revise any of the selections, add additional, we've got our pipe there, but if we want to add, find out more pipe options, we can go to our chemical resistant pipe or anything like that, find our Chimax. With every single one of our manufacturers, we are going to have the spec sheet built into the system as well. So if you want more details on flow rates versus pressure drops for sizing your backflow. If you want to understand, the recovery capacity of your water heater or anything like that. All the manufacturer sheets with all their flow curves and particular details. In this case, the lengths, the weights, diameters, inner diameters, everything like that, all your curves. Those are all included in the manufacturer spec sheet, and then you can configure your selection to match exactly what you need for your particular project, master, or quick spec. Once we're done and happy, we can go back to our project. Anything with the checked off box is going to get included as we download. Really wish this disappeared. Silly Zoom. We can apply our automatically approved alternates. We can download our spec and select all the different format options, manufacturer spec sheet, Revit files, 3 different types of Word spec, CSI, long, short, schedules in Excel, product brochures, which show just the limited details and the key images, submittal, which shows exactly what you want in a PDF format. And I've got them open here because no offense, Owen, I do kind of assume that you're always going to leave me a little short on time. And then we've got our manufacturer spec sheet format, which comes with a nice handy title page, exact model name and number you selected, and then again, the model specific cut sheets, our submittal format, which again shows exactly the model name and number selected. And then our written specs in short format, written specs in longer format, schedules in Excel, Revit, all of it. That's the end goal. Provide all the different formats that you could possibly need to insert this into your documentation. The goal is to align with what you already have and supplement your workflow. So if you have any questions on getting this set up, that's what my team is here for and happy to do. We do master reviews and updates all the time. That's the majority of my day is either updating the master or teaching the team how to utilize that master on the spec tool. Once we get that in there, we're happy to work with your team and do one-on-ones, do small group sessions, do full lunch and learns. If you would like a lunch and learn on the subject that we covered today and dive into corrosive waste, maybe you have specific questions or you have a specific application or specific pharma group that you're working with that you want to understand how the glass piping or how the acid neutralizers can tie into that, or even if you want to better understand the coil identification and pipe identification systems or trap seal priming or water hammer arresters, everything else that we have with the SMS crew. We're happy to do that as well and deep dive any questions you have. Thank you once again, Owen, for a terrific presentation. You always provide great insight, code focused discussion, and I'm always appreciative of you joining us.
My
So
pleasure
thank
as
you to
always.
those that attended. Thank you to Owen for relaying the information. And I think we'll see you again next week. Have a great rest
Yeah,
of the day. Bye for
take
now.
care.